Hi everyone, myself Kavya, he is my teammate Sriram, and our mentor is Mr. Akshay Kumar. Today I am going to explain a problem vowels in a Window-1. In this problem, we will learn how to count the vowels in a substring using a different approaches, starts from a every basic brute force method and understanding why it works. Let's come to the problem statement. You will be given a string S of length n and window size k. You need to print the number of vowels present in the each window by sliding it till the end of the string. Here there are constraints are 1 less than or equal to t less than or equal to 1000. 1 less than or equal to k less than or equal to n less than or equal to 10 power 6. Here let's come to the example. Here the given string s equals to a b c d e. The here k equals to size of the window. In this string it is divided into three substrings a b c b c d d c d e. We need to find the substring of k size window of n size string equals to n minus k plus 1. For k equal to 3, n equal to 5, we need to find the substring equal to 3. We need to find the number of vowels present in the each window. Now let us take in first substring a, b, c. Here only the one vowel is present, so that window size is 1. Now let us move to the next substring b, c, d. No vowel is present in the substring, so that window size is 0. Now let us move to the next substring C, D, E. Here only one vowel is present, so that window size is 1. We treat each window independently. For every window, we check each character. If character is vowel, we increase the vowel count. In this approach is simple and easy to understand, but not more efficient. Let's come to the algorithm. In this algorithm, loop runs from the index 0 to n minus k. For each index, consider the substring of length k. Inside the substring, check every character, counts the vowels, print the vowels of the window. Example, let us take a first string a, b, c. If checking the each character, if a is vowel, increased count by 1. Checking the next character b is not vowel, so that count does not increase. Now moving to the next character c is not vowel, so that does not increase the count. So the total count is 1. Now let us move to the next substring b, c, d. Now let us take a first character b is not vowel, so that count does not increase. Now let us move to the next character c is not vowel, so that count does not increase. Now moves to the next character d is not vowel, so that does not increase. So the total count is equals to 0. Now let us move to the next substring. Checking the first character of the substring, c is not vowel, so that count does not increase. Now D is not a vowel, so the count does not increase. Checking the next character E is vowel, so the count increment by 1. So the total counts are 1. Total count is 0, 1, 0, 1. Complexity. The key problems in the brute force approach is for calculating the counting of again and again. The time complexity, total count of windows are n minus k plus 1. So approximately we takes the n. The total iterations per the window equals to k. So the time complexity, time taken equals to big O of n into k. So the time space complexity is big O of 1. Now my friend will continue this.
Hello everyone, I am Sriram. Let us understand the better approach. But before diving into the better approach, let us understand why brute force approach is inefficient. The time complexity of brute force approach is big O of n into k. According to the constraints, n and k can go up to 10 power 6. That means in worst case scenario, the time complexity can be n square, that equals to 10 power 12, but for loop can run only up to 10 power 8. So that's why brute force approach here is inefficient. So the better approach will be using this prefix sum logic. We use prefix sum logic because In prefix sum logic also we get the sum of the elements in the window in a constant time. Here also, to reduce the time complexity from n square to n, we need to get the frequency of the vowels in a window in a constant time. So this is the first big hint, and the second hint is that the frequency doesn't changes for a entire array or the entire string, but it only changes for the substrings or the window. That's why it is similar to prefixum logic. So we can use prefixum logic here to do this. But how do we use prefixum logic here? So can we know how many vowels appear up to a certain index? Like in prefixum, we know the sum of the elements in that window by using indices. So similar way, can we use indices to get the frequency of a certain window? Let's see how. So as I already said that prefixum can help us storing the number of vowels at a given index. So, so instead of storing the sum of elements, we simply store the count of vowels found till that index. That means prefixum stores the cumulative vowel count. That means the number of vowels identified till that index. So let us understand with a simple example. Let a string be A, B, C, I, D, E, F. At index 0, prefix count is 1 because A is an vowel, so character at index 0 is A. Since it is a vowel, the count will be increased. Prefixum value at index 0 will be 1. At index 1, prefix count will be 1 because the count doesn't increase as B is not a vowel. Same thing with index 2. But at index 3, we can see the character is I, which is a vowel. So count increased. Same thing with index 4 and index 5. But at index 6, D is the character that is not a vowel. So that's why count is 4. At index 7, again E is a vowel. So count increases. At index 8, F is not a vowel. So count will be 5. So I think you understand with this example. So let us see, is there any way to get a frequency using indices? So this is the formula. The vowels, the number of vowels in a window is equals to prefix of I plus k minus 1 minus prefix of I minus 1. Suppose if I is equal to 0, then take prefix of I minus 1 as 0. Again, let us understand this formula with a simple example. Let's see with taking two windows as example. First window is 2 comma 4 and second window is 0 comma 2. At 2 comma 4, we have CII. So 2, 3, 4 indexes. We have a small window CII. So in this window there are totally two vowels. So from the formula we need to get the answer as 2. So here prefix of I plus k minus 1. I is 2 and k is the window size, that is 3. So 2 plus 3 is 5 minus 1 4. So prefix of 4. Let us see the value at prefix of 4. Prefix of 4 is value is 3. Prefix of I minus 1, that is 2 minus 1 is 1. So the total number of vowels are 2. Same thing with the window 0 comma 2, but here I is 0. That's why we take a direct value of prefix of I minus 1 is 0, and at index 2 the value is 1. That's why 1 minus 0 is equals to 1. That means we at first window we have only one vowel. We can see in ABC, A is only the vowel. We have understood the approach and the thought process why only brute force prefix logic. So let us understand the algorithm. Algorithm is simply what we have done. Prefix array stores cumulative vowel count. As I said, this cumulative vowel count is nothing but the number of vowels found till that index so far. After prefix array of cumulative vowel count, for each valid window we subtract prefix values. That means we use formulas to get the answer and print result of each window. So the time complexity and space complexity for this approach is big O of n, because we are looping entire substring once, and then we are using extra space, that is array, to store the cumulative vowel count. But this is better approach than brute force. But is there any other way to reduce this extra space? Let us think, is there any other way? As in the question mentioned, each window you need to print the number of vowels in each window by sliding it till the end of the string. That means we need to print the values of consecutive windows. This is the first big hint, that is consecutive windows. Because in consecutive windows, from moving from one window to another window, there is, if you observe very keenly, you can observe two things. When the window moves by one step, how many characters actually change? Only two characters, right? One is entering the window and another is leaving the window. So only two characters change. One goes out and one comes in. The first count vowel is the first window. That means we need to count number of vowels in the first window, and then from the second window the sliding window starts. At each time one will be removed and another character will be added, then update the count. If there is a, if the incoming character is a vowel, we increase the count. If the outgoing character is a vowel, we will decrease the count because it is contributed to the count before. So let us understand this approach also with a simple example. Let S be A, B, C, D, E. So the first window will be, suppose if size k is equal to 3, the first window will be A, B, C. In the first window, the number of vowels is just 1. So the count is equals to 1. While sliding, since A is contributed to count as it is a vowel, we decrement the count value. So that's why count becomes 0. In the second window, A is removed and B is added, but D is added, but D is not a vowel, so the count will be same, not added. And after sliding again, the third window, A is entered and B is removed. Since B is not contributed to the count, so nothing is changed. That means nothing is decremented. So as E entered, E is a vowel, we increment the count. So this is the sliding window. Start with the first window and then move to second window, then move to third window, and entering and leaving characters will update the count. Let us understand this algorithm. This is the simple steps. See, as we have already discussed, we count the vowels in the first window, then we slide window from left to right and update the count. That means we add or we remove, then print result of each window. So the time complexity of this approach is